Hi everyone. So today we are going to discuss on another important topic which is called as greedy algorithms. In greedy approach, what we do that greedy approaches are basically used to solve the optimization problems. Now, what is an optimization problem? It is a problem where we have been given a set of values which are required to be either maximized or minimized with respect to some given constraints or the conditions. So, one important aspect about the optimization problems is that the input is given which are set of certain values, and we need to apply a function so that we are able to maximize or minimize based on given conditions. So it could be the value of the profit, or it could be the value of the cost. In case of cost, we want to minimize it, and in case of profit, for example, we want to find out a maximization function that can maximize the overall profit that I'm gaining with respect to the given constraints and the given set of values. So formally, for a given set of n inputs, we can say that this n number of inputs, these are considered as the candidate set C. And we need to find out a subset of C that satisfies the given constraints or the condition. Now, any subset X which satisfies the given constraint is called a feasible solution. So, out of the C, we need to select the inputs in such a manner so that we are creating a feasible solution first of all, and whatever feasible solution we are getting, that feasible solution should satisfy all the constraints. So, this is the important property of a feasible solution. Now, there could be multiple feasible solution out of a given input set, and the criteria is that we are only interested in finding out the best feasible solution for the given problem. So, how we can define the best feasible solution? So, out of all the feasible solution, again I want to remind that is one solution which satisfy all the constraints which are specified for the given problem domain. So, now if you have found out a set of all feasible solutions, I am only interested in finding out the one which is the best for the given problem. So, this is a feasible solution that actually maximizes or minimizes a given objective function. Now, the feasible solution which we got is called as the optimal solution. So, the name optimal solution comes from the fact that it is the solution which either maximizes or minimizes the value for certain cost function. So, this cost function could be again the profit, or it could be representing the overall cost or some distance as per the problem. Now, a greedy algorithm proceeds step by step, and it considers one input at a given time. At each stage, the decision is made regarding whether a particular input should be chosen, and if we are choosing this specific input, say for example, the ith input out of all the input sets, if we are choosing it, it gives us an optimal solution or not. Now, we will discuss about the characteristics of greedy algorithms. So, as we already have seen that in greedy paradigm, what we do that we are trying to greedily find out the best possible option or the best possible solution for a given problem within given certain within given constraints that we have with us. Now, when we talk about the characteristics, so first of all, the greedy approach or the paradigms is mostly used to solve the optimization problems where we need to either maximize or minimize certain function. Now, the second important aspect is that most general and straightforward method to solve a given problem domain. So, in another way, we can say that the greedy algorithms, they are the most straightforward method after the brute force method, and we are easily able to solve a problem, or we are easily able to devise a greedy algorithm for a given problem domain. So, thus we can say that greedy approach and the greedy algorithms, they are easy to implement and they are very efficient. Why efficient? Efficient because it is giving you the solution within given constraint, and it generates a quick solution for us. This property I want to discuss here is that when we say that we are getting a greedy algorithm for a given problem domain, for example, which gives us efficient time complexity. So efficient means because you are not trying to explore all the possible solutions, rather you are checking for the local best options at a given step, and you are choosing your candidate from those local optimal values. So that way we are quickly reaching to the overall solution, which we called as the the final solution or the optimal solution. And of course, every greedy algorithm hopes that while it is selecting the best option, the local best option which is available at a current moment of time, that will lead specifically to the global optimal solution. So the overall goal here to find out the global optimal solution, but as we already have seen that greedy algorithms, they make prompt choices, and just by looking at certain given options which are currently with us and choosing the best option from those choices which are available at the particular moment of time. Now, once any choice of input from candidate set C is rejected, then it can never be considered again. So once we have rejected, for example, a particular input, then in future we are not able to reconsider it again for building up the optimal solution. So this is another important aspect. Now as the name suggests, greedy approaches, since greedy only checks for the local possible solutions, we are not trying to find out the global we are trying to find out the global solution, of course, but we are not waiting for exploring all the possible solution in a way to find out the global optimal solution. So this says that sometimes the greedy algorithm can generate a global optimal solution, but for many problems it may happen that the greedy is not giving you the global best solution for a given problem, rather it is only generating certain local optimal solutions for you. Now there are variety of problems that we can solve with the help of the greedy algorithm, and certain greedy algorithm the problems which are being solved by the greedy algorithm, they can also be solved by different other paradigms. So for example, the knapsack problem is the one problem instance that can be solved with the help of greedy approach as well as with the dynamic programming approach. Since we are only introducing here to the greedy algorithm, the first problem that we are going to take here is the knapsack problem. So if you remember, there are two versions of knapsack. One is called as the 0-1 knapsack and the other one is called as a fractional knapsack problem. What is the difference between these two? So first of all, we need to know what the knapsack problem is. So in the knapsack problem, we have been given a knapsack with a given maximum capacity, which is denoted as W. Right? So this is the capacity of the knapsack that we have with us. Now we are given a set of items, for example, I1, I2 up to In, and each of these items is going to have certain weight, which is represented as W1, W2 up to Wn, and every item is also associated with a certain profit. So every item which I pick from this set of n objects or items, whenever I am picking up that object and including it into my knapsack with capacity W, what will happen? That certain weight will be included inside the knapsack. So of course, the capacity of the knapsack is going to be reduced by this whenever you are picking up items, and the profit margin that we have, that profit is going to be increased. And how much profit we are going to earn, that depends upon what profit value is associated with each and every input item, right? Now, I need to find out a sequence of these, I need to find out the set of, basically the set of all the items that I can pick up, so that I am making the maximum profit with the knapsack. Now, we need to understand here that the constraint here is nothing but the capacity of the knapsack itself. So, I cannot add on the items which are exceeding the capacity of the knapsack. So, if your capacity of the knapsack is, for example, 20 kgs, I cannot pick up items which are exceeding the weight or the capacity of the knapsack. I only can, carry 20 kgs of weight at the max by using this knapsack with me. So, in this case, the constraint is what? The constraint is the capacity limit of the knapsack itself. Now, I need to find out how much maximum profit I can earn by including objects or the items from my set of items. The next thing that we need to know is that what is the difference between 0-1 knapsack and fractional knapsack. So, in case of 0-1 knapsack, what happens that either we are picking up a certain object or we are completely leaving it behind. And as the name suggests, that when we are applying the greedy approach, in case of greedy approach, we cannot go back to the option or the choice that we already have left out. So, the basic difference between the 0-1 knapsack and fractional knapsack is that in case of 0-1 knapsack, either I am picking up I1 or I am rejecting I1 completely. Okay. So, normally when we are solving the problems, in case of 0-1 knapsack, when we are picking up, for example, the item 1, we select it and this fact is being represented as a bit set to 1. So, that bit shows me that in my solution, I have selected the first item. So, if the corresponding bit here is set to 1, then I can say that I1 item is selected out of this list. Now, for example, if for I2, if I am keeping this bit as 0 in the solution vector, then that shows that item I2 is not included in my solution list. Maybe this could be because I'm not getting more profit, or it could be the scenario where the constraint, which is the capacity of the knapsack, is going to be exceeded by adding up I2. So, I need to be careful that while we are solving the 0-1 knapsack problem, the thing is that either we are completely taking up the object or we are completely rejecting that particular object. In fractional knapsack approach, what we can do, that apart from choosing the whole object as is, and we can keep it to the knapsack, we also can take out certain fraction of the object and we can add it to the knapsack. So, that way most of the time we can get that the capacity W that we are having will be equal to the current capacity of my knapsack, right. So, in this case, this could be the most appropriate thing that we can encounter when the capacity of the knapsack is completely runs out. Runs out means that we are able to add up item in such a way so that every time the difference between the weights of the items and my capacity will eventually becomes 0. So, that means that I am not leaving behind any space in the knapsack, and I am able to fit as many objects as I can, even though I am taking out certain fractions of objects from my list of items. Now, the next thing is that with greedy approach, we are able to find out the solution of the fractional knapsack but not for the 0-1 knapsack. So for 0-1 knapsack cases, we do not apply a greedy algorithm, or we do not devise a greedy algorithm. Rather, for the fractional knapsack, we are going to solve it with the help of the greedy approach, and most of the time we are getting the optimal solution with the help of greedy algorithm. Now we will see that how we are going to proceed when we are devising a greedy algorithm step by step to solve the fractional knapsack problem. So we have been given an objective function, and we need to maximize this objective function. Here you can see that the objective function is that I need to pick up the ith object in such a way that the profit value which is associated with the specific object or the ith object is going to be included, and this I have to do within the capacity of the knapsack itself, which becomes the constraint. So that way we have devised it like maximize the xi pi, and then we need to check for the constraint which is specified as that whatever objects you have included into your knapsack, the total weight of these objects must be less than or equal to the capacity of the knapsack. So this is the formal way of devising a greedy algorithm. Now, what are the steps exactly that we need to follow to solve this knapsack problem using greedy algorithm? So step 1 says that for every item I need to first compute the profit and weight ratio, right? And this is represented as Pi over Wi. The I represents here the ith object that we are picking up, and whenever you are taking up the ith object from the list of all the objects which you have with you, certain weight is going to be added to the knapsack, and thereby the capacity is going to be reduced by this value, the weight of the object, and the profit that we are earning is going to be increased by the value of Pi. The step 2 is that we have to arrange all the items in decreasing order of their profit and weight ratio. So once you already have found out the profit weight ratio for each and every item, now I need to arrange or sort all these items with respect to the profit weight ratio, and we need to sort it in a decreasing order, so that the item which is having most or more profit weight ratio comes in the beginning of the list, and the ones which are having less profit weight ratio, those are coming towards the end. In step 3, we are starting to putting the items into the knapsack beginning from the item with the highest ratio. So we will pick up the item which is having the highest this profit weight ratio first into the knapsack, and then we will calculate the remaining capacity of the knapsack and how much profit we have earned with the current situation or the current state, and then we are trying to add more items to it. And whenever there is a chance where the knapsack capacity does not allow to include the whole object into the knapsack, what we will do, that we will take out certain fraction of that particular object which is having the next highest profit weight ratio, and we are putting that fraction into the knapsack, so that the overall weight of all the objects which we have included inside the knapsack, that becomes equal to the weight capacity of the knapsack. So this is one example that we have taken up here. So for example, we have been given a problem where the capacity of the knapsack is 60, it could be 60 kgs for example, and we have been given 4 items, item A, B, C and D, right? Now for every item we have been given the profits and the corresponding weights of these items. So we need to apply first the step 1. So step 1 says that we need to first find out the profit weight ratio here. So this is represented as an additional row here, and we are finding out the profit and the weight ratio of each and every object which is given to us. So you can see that for object A we are having a profit weight ratio of 7. Then for B, we are having 10. For C, we are having 6. And for D, we are having a ratio of 5. Now, as you can see that B object is having the highest, ratio. So now in the next step, we are arranging or sorting these items based on these, values of the profit weight ratio. So here you can see that we have sorted, and B is the first item now in the list because it is having the highest profit weight ratio. Then the next decreasing, we have arranged it in a decreasing order, and you can see that the next highest ratio is 7 belonging to item A, and then for item C, then for item D. Now what we have to do, that we need to pick up the first object from here, which is having the highest weight ratio. So the first object that we are picking up here is, we are choosing B. We can write that pick B, and once you are picking up B, in that case what will happen, that I need to calculate the weight left and the profit which I am having. Currently we can set the profit value to, for example, 0, right, when no object is being added to the knapsack, and the weight of the knapsack is the given value, which is 60, for example. Now, for example, if I pick up B, then in that case, I am going to proceed that once you pick up B, the weight left, I can write it like weight left will be equal to W minus weight of B. I can write it weight of B, for example. So weight left will be equal to W is 60 here, and weight of B, so weight of B is 10. So the remaining weight of my knapsack after adding B will be 50, and the profit value will be, the profit that I am earning will become 0 plus profit of B, for example. This will come to 100, as you can see here. So 0 plus 100, now you will get a profit of 100 rupees. Okay, so that way we have first added up the first object here. Now next what we are going to do, that we are picking up the next object and we are checking the constraint, and this constraint is nothing but the capacity of the knapsack. So if I'm able to include this object into my knapsack, my constraint is satisfied, and that way the profit value is going to be increased by some margin, and the weight is also going to be increased up. So for example, the next object which is having the next highest weight, this profit weight profit ratio is item A. So now you are picking A, and for A, now again I need to calculate the W left. W left will be equal to the W is now reduced to 50. So 50 minus, when you are picking up object A, you are adding up a weight of 40 here. So you will write 40. So remaining capacity will be 10 here, and now the profit will increase and it will become 100 plus profit of A, which is equal to 280. So now you are getting 380 profit units with you, right? This way, now we are proceeding to the next item. Now, as you can see that when I'm trying to add a object C here, it carries a weight of 20 units, right? But the left or the remaining capacity for my knapsack is only 10. So now since I only have left with 10 weight units, and the next item that I need to add up is having more weight than I have left with the knapsack, what I will do, that I need to take up a fraction of this object. How much fraction I am taking? Whatever the remaining capacity of the knapsack is. So that way we are finding out the weight left. So here this is the current capacity which is possible with the knapsack value, and 20 is the weight value of this object, right? and we need to find out the ratio 10 by 20. I need to draw 10 kgs out of this 20 kgs because only the 10 kg capacity is left for the knapsack right now, and that way my bag will become completely full, full, and the profit value will increase from 380 to 440. So as you can see that here the value or the profit which is associated here is 120 units, since you are only taking up half of the fraction of this particular object. So the profit value will be reduced and you are only adding up as much profit as corresponds to the weight units that you have selected for this particular object. So that way the final solution that we will get for this given problem instance using greedy approach will be 440 units of profit margin. So that is all today. These are some of the references, and thank you so much.